You had a line that looks like this, 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 and I was in a hurry, so I said some things that I shouldn't have said in the order I said them. We'll take a little more time today to sort that out. 15. 6. This is 9. Okay. This is time in seconds. Okay, so question A. Mr. Combs.
I'm not gonna. I have an issue with this.
Well, that's why I'm calling you, man. You're gonna help me out, right?
I hope so.
Okay, so this is a velocity time graph. Say that with me. You're the velocity time graph?
Velocity time graph.
Okay. Since it's a velocity time graph, in the first 3 seconds, how much did the speed change?
Would that be the slope?
No. That's what I did wrong. I gave you too much information.
That's what I thought.
It's speed. Look at the speed. It's a velocity time graph, right? So that's speed.
Yeah.
So what's the speed at time equals 0?
Really 0?
What's the speed at time equals 3?
10?
So how fast is it going after 10 seconds? I'm sorry, how fast during the first 3 seconds, how much did it change the speed?
0 to 10.
0 to 10, which we'd say is 10 seconds. 10 meters per second, right? So the correct answer, first question was 10 meters per second. That's on me. I was trying to jam things in at the very end.
That's all it is.
That's it. That's the last one. The second question you're going to like even better, although if it fools you, you're going to be angry. So listen carefully. It won't fool you. Just take a deep breath. Ready? During the first 3 seconds, what's the change in time? I repeat the question. During the first 3 seconds, what's the change in time? It is a trick question. It's so easy, it's a trick question. During the first 3 seconds, how much time has gone by?
3 seconds?
3 seconds, excellent choice. Good job there. So you have a right to be angry. So you just told me that during the first 3 seconds, the speed has changed 10 meters per second, and the time has changed for 3 seconds. Okay, agree on that so far?
Yeah.
What's its acceleration therefore? It's changed 10 meters per second in 3 seconds.
So 3.333.
There you go. So the acceleration would be 3.33 meters per second squared. Okay, and that's the answer to C. I made the answer to A. That's on me. I was trying to go fast. So the next line is, the acceleration is the blank of a speed time graph. Okay, let's take a look. What you told me is that the velocity went up 10 and over 3. When we say rise of 10 and a run of 3, what are we really talking about?
Slope?
Slope. So the acceleration is the slope of a speed time graph. Now that we know this slope is an acceleration, sir, is the acceleration greater between 2 and 3 seconds or 5 and 6?
5 and 6.
5 and 6. Is it changing the speed faster because it's steeper the slope? Yes. During what time is the acceleration 0?
3 to 5 seconds.
3 to 5 seconds. Its speed's not changing, so its acceleration has to be 0, right?
Yeah.
Also, its slope is 0. Is this thing kind of gelling a little?
Yeah, it's pretty easy.
Oh man, you just said easy in an AP physics class.
Okay, not easy.
Dude, you walk out in the hallway, show them the graph, ask that question, see what happens. There aren't many kids, not many adults that can answer that question. Pretty easy. All right, G. What's the displacement between 3 and 4 seconds? Now you have to think back a little ways because we talked about this a while ago, but not recently.
Would it be 0?
Displacement, it's how fast is it traveling at 3 seconds?
Oh, 10.
10. So it can't really be 0, right? It has to have gone somewhere.
So it would be 10?
Why would it be 10?
Because it's the velocity.
It is 10. So don't say, oh, never mind. Talk to me.
Because at 3 seconds, the velocity is 10 meters per second.
And it's for 1 second, and the velocity doesn't change. That's really, really important, the last part of that sentence.
Velocity is not changing.
But I taught you something different. I said To find the displacement, you need to find the area underneath the curve. So if this is 10 meters and this is 1 second, 10 meters by 1 second, 10 meters by 1 second is going to be 10 meters, the area of this curve. Is that okay?
Yeah.
Because that's going to work here when your 10 times 1 won't work. Because it's changing, right? You can use the 10 or use the 15. I don't know. Okay, here we go. It's between 6 and 8 seconds. What's its acceleration?
Would it be 10? 10 again?
Except it's over 2 seconds. How much should it go down? Here's 8.
What's a 10 meter velocity change?
Right, and it did so in 2 seconds though, right?
So 5.
So 5. So 10 meters per second in 2 seconds, which is negative 5 meters per second squared. Negative meaning it's slowing down, right? We said that before. Look what happens. Your slope's negative, the speed's going from 15 back down to 5, so I am slowing down. And that makes sense. Oh, dear gosh, I'm making a mistake here. I have to add something in here. I probably made a mistake someplace else. I have to add the word north. Why? First of all, it says the positive direction is north for this problem, right? And so therefore, I have to add, whenever I say acceleration, I need a direction because it's the vector one. Okay? That's on me. I haven't expressed that enough. Is that okay with you?
Yeah.
Okay. So if you back up, that answer we had right here, that's 3.33 meters per second squared, I wrote down. That also should have a north on it. Now, who wants a bonus question? The twister question, the question that breaks your head. Could I write this a different way? This negative 5 meters per second squared north? How can I write it?
Negative 5 meters per second over 1 second.
Yeah, that's true. It's not what I'm looking for. What does negative mean? What does negative always mean? Meant. Wrong word. Meant. If I am walking this way, what does negative walking that way mean?
Backwards.
It means walking backwards. So negative 5 meters per second squared north could also be written as
So,
5 meters per second squared south. Legit. And then GS for displacement, so I should have had 10 meters north there, right? Because displacement's the one that's got a vector on it, so that's on me. Start fixing that, so I'll take away points on the test. That's really mean since I messed it up when I first explained it, but you guys have to take care of that for yourselves. How about I? Between 5 and 6 seconds, what's my displacement? What did you say, 5?
Yeah.
Okay, why?
Because you're going, the velocity change is 5 in 1 second.
That's acceleration. I wanted how far it went. How do you find how far it went? We talked about that just a moment ago before I confused you.
Oh yeah, the area.
Area. Now, since most of you don't know the trapezoid formula, I recommend breaking it into a triangle and a rectangle. Is that okay with you?
Yeah.
This is going to be 10 times 1, because that height is 10 and this is 1. The triangle is going to be, what's the formula of the triangle? Combs?
What? You do the times inside by the divided and then divided by 2.
Ew. 1/2 base times height, which is, what you said is correct. And so 1/2, 1 times 5. So that'd be 2.5. So what's the total distance it travels between the 5th and 6th seconds?
12.5.
12.5 meters. Since I asked for displacement, what are you going to tack on?
North.
North. All right, everybody, what's the displacement between the 7th and 8th second? How about?